To solve this system of linear inequalities, we will graph each inequality separately and see where the shading overlaps. To graph the first inequality, we will begin by looking at the equation for the boundary line, which is replacing the inequality symbol with an equal sign. We will find the x-intercept by plugging in y for 0. Sorry, 0 for y. We're solving 3x equals 6, giving us x equals 2. To find the y-intercept, we will plug in 0 for x, leaving us with 2y equals 6, and we get y equals 3. Because the symbol is less than or equal to, we will connect these with a solid line. To determine where to shade, we can do our test point of 0, 0. We will plug in 0 for x and 0 for y in the original inequality, giving us 0 less than or equal to 6, which is true. Because the test point made the inequality true, we will shade toward the test point. For the other inequality, again, we will start with that boundary line. That will be y equals -1/2 x minus 3. Here we can use the fact that the slope is -1/2 and the y-intercept is -3. So we'll start with our y-intercept. Our slope is up 1 over 2, and we're moving in the negative direction because it's a negative slope. Because this symbol is simply greater than, we must use a dotted line when we connect them. If we do our test point of 0, 0, we end up getting 0 is greater than 0 minus 3, which is -3, and that statement is also true. Because it is true, we will shade toward the test point. If the statement would have been false, that just means that we would shade away from the test point. Now we want to only shade the part where the shading overlaps, which will look like this, and that is our solution.